Okay, let's go over quiz 2, arithmetic with rational expressions. What this is about is we have rational expressions. We have three rational expressions, P of x, Q of x, and R of x. And we're going to perform arithmetic. What that means, we're going to add, subtract, multiply, and divide. Um, so let's do that. The way it is defined right now, it says P of x is equal to this rational expression. Q of x is equal to this rational expression, and R of x is equal to this rational expression. So we have three rational expressions, and then we have to find the following and identify any exclusions, which means any undefined values. Number one says, take P of x and multiply by Q of x. What that means is we're going to take P of x, which is this one right here, and Q of x, and we're going to multiply them. And hopefully it'll reduce since it's fractions, and we have a final version of it. So P of x is this, but I could just copy it down. Well, let's just do that. This is x squared plus x minus 6 over x plus 4 times x plus 4 over x squared plus 3x minus 10. Okay, so I'm going to go ahead and put this parentheses because it's by itself. So this is a multiplication, right? We're going to multiply this by that. We have two fractions. How do we multiply a fraction? We multiply straight across. The two top ones, this times this, and then this times that. For example, if I had 1/2 times 3/4, this would be what? 3 over 8, right? That's how multiplying fractions work. So right here, we're just going to multiply. But then before we do that, we see that we have an x plus 4 here at the top and an x plus 4 here at the bottom. If you have factors that are on opposite sides of the fraction, they do what? They cancel each other out. So my fraction now is going to be this over that. But before I just rewrite it, we can actually see if anything else cancels out on the next fraction by factoring these two expressions. This is a quadratic, so I can factor this more than likely into two factors. So, and then the bottom one, this one, we're going to also factor. And hopefully, if any of these match, they cancel out, right? So what are the factors of this one, of this expression? Well, we have -6. We're going to look for the two factors of -6 that add up to 1x, right? So the factors of -6 is going to be 2 and 3. One of these has to be negative. This is a positive, so that means that the 3 is positive, and this one's negative. 3 minus 2 is 1. So my factor right here is going to be x minus 2, x plus 3. And this one right here, if we were to factor that one, we're looking for the factors of -10 that are going to add up to 3. So the factors of 10 are 2 and 5. One of these has to be negative. This is a positive 3, so the 5 is positive because 5 minus 2 is 3x. So my two factors are going to be x minus 2 times x plus 5. So what cancels out? This one cancels out. So my final, the only factors that remain, the only terms that remain is x plus 3 at the top and x plus 5 at the bottom. Okay. It also says to identify any exclusions. Exclusions means anytime this falls apart, anytime this doesn't make sense. Now, a fraction is like a division problem, which means I cannot divide by 0. So I'm looking at the denominators. I'm looking at this. When is this equal to 0? When x is what? -4. So x cannot equal to -4. What about this part right here? Because I'm looking at the original one, right? This part, we saw that we could factor it into this, right? So x cannot equal to 2 because 2 minus 2 right here is 0. And it cannot equal to what? -5 because -5 plus 5 is equal to 0. So this is the reduced version of that. P times Q is this. This times that is equal to this after it reduces. Number 2 says Q of x divided by R of x. So right here, I'm going to take this one and divide by R of x. So this is going to be x plus 4 over This one I had already factored, right, from the first one. So more of the factors, it was x minus 2 times x plus 5. Now I have to divide by r of x. So I could divide right here by 1 over x minus 2. But this is dividing a fraction. How do we divide a fraction? By multiplying the reciprocal. We're going to switch. We're going to flip this r. And we're going to multiply by x minus 2 at the top over 1. Right? That's how we divide a fraction. We multiply by the reciprocal. So now if we multiply straight across, we have x plus 4 times x minus 2 over, look at this, we have these two cancel out, and all I have left over is x plus 4 over x plus 5. Okay, now what about the exclusions? Any values that make the denominator equal to 0 is going to be 2 and negative 5 right here. Let's keep going. Number three says, given P, Q, and X. So is the same ones? Is it? Yes, it's the same ones. So it's the same problem. Well, actually, yes. So it's the same problems. So they're going to factor out the same. Let me just double check one more time. Yeah, it is. So number one, I should have said 3, but number 1 right here, this time we're going to add Q and R. We're going to take this and we're going to add that. So let's do that really quick. How do we do that? We're adding fractions. This is going to be x plus 4, Q of x is this one, over x squared plus 3x minus 10 plus 1 over x minus 2. Now this one right here, before we add or subtract fractions, the only way they combine is if they have the same denominator. For example, 1/5 plus 2/5 is equal to 3/5, right? You have 1/5 of a slice plus 2/5 of slices is equal to 3 of 5 slices. So we have to make the denominators the same. So how do I make an x minus 2 into this? Well, let's break this one down into its factors. This is going to be x plus 4. Now this one we had already factored it from the other problem. This was actually x minus 2 times x plus 5 plus this one. So we're going to add the second one. And so now the question again is, how do I make this x minus 2 into x minus 2 times x plus 5? Well, you see that they have this one in common. All it needs is the x plus 5. So we're going to attach it. How do we attach it? We're going to multiply it. We're going to multiply x plus 5. But the thing is that if I do it at the bottom, I have to do it at the top. Why? Because this is essentially 1. These two cancel out. It's just like I'm multiplying 1. So I'm not changing anything. It's just going to look a little bit different. So we're going to go ahead and simplify this. This is going to be x plus 4 at the top. X plus 4 plus 1 times 5 is x. We're going to distribute the 1. And then 1 times 5 is plus 5. So x plus 5 over my new denominator. You see how up here we have 5. When I add these two, it just became one fraction. Well, this becomes one fraction. X minus 2 over x plus 5 is my new denominator. And then we just combine the like terms. We have x and x is 2x. So 2x plus 9 over x minus 2 times x plus 5. And that's it. Oh, my exclusions here. What is going to be, this is the final version. So what numbers can I not plug in here? It's going to be x cannot equal to 2 and negative 5. And that's it. What about the last one? Last one is subtraction. So subtraction works just like addition. That's why they're grouped together. This one is going to be q minus that one. So let's set it up. It's going to be x plus 4 over, let's go ahead and factor this one from the one we just did. So this was what? X minus 2 times x plus 5. and we're going to subtract 1 over x minus 2. So this is very similar, just like that. Instead of a plus, we have a minus here. So again, minus works just like addition. Before we combine these two fractions, these two rational expressions, the denominators have to match. So what's missing on this one? This has an x minus 2, x minus 2. The x plus 5 is missing here. And so I'm going to multiply it at the bottom and the top. And then I'm just going to distribute after that and simplify, combine everything together. So it's going to be x plus 4. And this time is going to be minus everything that comes after that, right? Which is going to be 1x. And then 1 times 5 is plus 5. Over, now I have just one denominator, x minus 2 times x plus 5. And be careful here. It kind of looks like I can cancel these two out, but that does not work out like that. Why? Because this is how it works. Whenever I have factors, x times y over x times z, these x's cancel out. But this is not. This is like x minus y over x minus z. So these do not cancel out. It has to be factors. Okay? So back to over here. We're going to have to simplify and combine the like terms. Over here, we're going to have to distribute the minus. So it's going to be x minus x is going to be 0. Those two cancel out. X minus x is 0. And then 4 minus a 5. 4 minus 5 is negative 1. So this is negative 1 over x minus 2 times x plus 5. And that's all. That everything has reduced. I cannot reduce it further than this. And again, my exclusions here. What can I not plug into here? What would make this bad? If I plug in a 2, because that would be divided by 0, and a negative 5. Okay, and that's it.